This video is a continuation with exponential functions, and it's about writing the equations. Okay, so previously we looked at exploring them, we created a table of values, and we looked at the graphs of exponential functions. And hopefully you remember that this graph on the left, it would have arrows and be continuing in either direction. This one is sort of increasing from left to right, and it is called exponential growth. Okay, on the left-hand side over here, it's sort of approaching zero, but never actually touching it. The values are getting smaller and smaller and smaller. Okay, and that's one of the features. And the other feature is that there was this y-intercept of 0, 1 that was common to many of the functions. Okay, and this one on the right is sort of decreasing. I think you can see that this is called exponential decay. Okay, for it to be decreasing. Same thing, it continues on to the right here and approaches 0 and gets closer and closer, but never touches it. And still has a y-intercept of 0, 1. Okay, so for all these exponential functions, they have equations that are of the form y equals ab to the exponent x. So the one way we can see that they're exponential functions as opposed to quadratics or linear functions is that you can see that the variable is in the exponent. Okay, this b value is our base, which we would also call our growth or decay factor. We'll talk more about that with examples. And then this a value right here is what we call the initial value. So I'll show you what I mean with this first example. Okay, so in this example, here's a table that represents an exponential function or relation. And hopefully you can easily see here that the initial value, this x comes before y, the initial value is 4. Hopefully that makes sense to you in this particular one. So that's our a value right there. Our initial value is 4. Now, the reason we know this is exponential, number one, because I tell you, but also take a look at the y values and note that they are doubling each time. So hopefully you can see that there's a pattern there. They are doubling or multiplying by 2 each time. So we would say that the y values are doubling. Clearly, this is exponential growth, and that means that the growth factor is a 2 because it's doubling. If it was tripling, it would be a 3. If it was quadrupling, it would be a 4, and so on like that. So let's put it all together and write the equation. So it's always going to start off y equals. We're going to use our initial value, which is 4, and then in brackets, we're going to put our base or our growth factor, which is a 2, to the exponent x. Okay, so let's try another one of these. This one's a scenario, not just the table of values given. Okay, so in this scenario, Sally upgraded the operating system on her phone. She was super excited about the new features, and so she phoned 2 friends to tell them. They then were super excited about the new features, and they've each phoned 2 friends, and then this continued until the whole school knew. Okay, so we're going to create a chart representing this scenario. You've seen this scenario or heard of this idea before, that's for sure. So in stage 0, we just have Sally. She's the only one that knows. That in stage 1, she goes ahead and she calls 2 people. And then each of those 2 people call 2 more people. So by stage 2, there are 4 people that know. And I think you can see that we're just creating a table like this. Okay, so first of all, just looking at the table, hopefully it makes sense that we are definitely talking about exponential growth again. The initial value is found in the table when x is 0, or at the beginning. There's one person that knows, it's Sally. And again, I've given you an example where I think you can see that it's doubling each time. We'll definitely have to do one without that, but that means that our b, or our base, is 2. So put it together for the equation. It would be y equals, initial value is 1, and it's again a doubling pattern. So it's 2 to the x. Okay, so one new thing I want to show you is how you would answer a question like this. How many friends will know about the features after 10 rounds of call? So hopefully it makes sense to you to take the equation. I should actually say as well that the equation could also be written. You don't actually need the 1 there since it is 1. You can just write it as y equals 2 to the x. So hopefully it makes sense to take the equation and in the spot of x, we're going to put 10. And then we're just going to punch that into our calculator, and we get 1,024. So therefore, by round 10, 1,024 people will know. Sorry, people. Okay. Now, I do just want to talk about one other question since I gave you both growth factors of 2. I want to just take a look at another one. So let's just take a look at C here in your practice. Hopefully you can see some of these conclusions that we can come up with, and hopefully they make sense to you. So first things first, I look at it and it looks like the Y values are going down, right? They're decreasing. So that's going to tell me that it's decay. Okay. Initial value is going to come from the place where x equals 0, the first row in the table often, and so our initial value is 80 in this particular one. And here, in terms of our growth or decay factor, hopefully you can see that these are sort of getting cut in half each time. Okay, so we can say that they're being multiplied by a half or divided by 2. They both mean the same thing, but I just think of it as they're getting cut in half each time, and so that means our growth, or in this case decay factor, is a half. Okay, so let's put it all together. We have y equals, we take our initial value, our growth or decay rate or factor is 1/2 to the x. Okay, so you're going to practice some more of that.